Alright, in this video I'm going to be talking about systems of equations. We're going to be doing the worksheet. So if you have the worksheet that I gave you in class, you'll see that it says you can do it with either substitution, graphing, or elimination. And there are, let me see here, 20 questions. So I'm going to take the approach of every other one. I'm going to use a different way. So first one, I'm going to do substitution. Okay, so this means that y equals this bad boy. And so everywhere I see y in the second equation, I can fill it in. So my equation would look something like this. All right, so I have the distributive property going on here. So I'm going to distribute that through. Negative 3 times a negative 11 is a positive 33 equals negative 7. Next thing I need to do is combine my like terms. So I have a negative 20x plus 33 equals negative 7. Okay. All right, I have to come up here because I need to subtract this 33 from both sides, which is going to give me negative 20x equals negative 40. Now I need to divide both sides by a negative 20, so x is going to be a positive 2. All right, now I can solve for y by putting this back into the original equation. Remember, it has to be the original equation, okay? 6 times 2 is 12, minus 11, it's 1. Now I got to write my coordinate pair. X always comes first. Remember, X comes first in the alphabet, so it comes first here too. All right? So our answer is 2, 3. That's our coordinate point. That's our point on the graph when it would intersect. So the next style I'm going to do is graphing. It was a little excessive, that side of the line, but oh well. So I'm on number 2, by the way. So 2x minus 3y equals negative 1, and y equals x minus 1. All right, so to do this, both equations need to be in y-intercept form. Now, I got the second one already in there, so I'm going to go ahead and graph it. All right, so I need to, put some numbers on my graph. Let me do that real quick. So graphing is not an exact science whatsoever, but I'm going to do the best I can with it. Okay, so my slope-intercept form tells me that the y-intercept is a negative 1. Let me change my color. Negative 1. And there's nothing in front of the x, so I can say it's 1 over 1. Okay, so I go up 1 over 1, up 1 over 1. Now I'm going to make just a small line until I see what the second one is doing. Okay, I don't want to, make a big old line and then it's all messy. I want to see where I need the line to go first. All right, so the first thing I need to do is change this first equation into the y-intercept form. That's where y is isolated and by itself. So the first thing I need to do is subtract the negative 2. Next, I need to divide everything by negative 3. Now this one's not the best to do this form with because of this 1/3, okay? So my y-intercept is right here, okay? It's kind of blue. I don't know what it's doing, but I know I have to go up 2. So 1, 2, and I have to go over 3. 1, 2, 3. So it's about there, okay? Let's do it again. 1, 2, 1, 2, 3. So my line is going, this one was not a good one to do. Try to get that as straight as I possibly can. And then I need to go back to my other one and finish it out. So I can go up another one, and then over one, go up another one, and over one, and I'm hitting about there. So now I have to make a guess. This is why the graphical method is not the best method, but it's good for you to know because it's easy to know if you got the right or wrong answer if you can visualize the graph. Does it make sense? Okay. I had two positive, very close together y-intercepts and two positive slopes. So the first quadrant for them to cross is pretty probable. That's the one I would probably guess. And I'm going to guess that it's about 4 and 3. Okay, so graphing is a little bit more like a guessing game. That's why it's not the best method to use, but it is a viable method to use. Okay, let's do number 4. Or number 3. Sorry, I skipped over 3. So now I'm going to do elimination. To do elimination, both equations have to be in standard form, which means I need to bring this to the other side. All right, so my equations will be 3x plus y equals 5, and 5x minus 4y equals negative 3. Now, you can pick whichever term you want to make the opposite, same but opposite sign one, so that it goes to a 0. I'm going to pick my y's because I have no coefficient. The coefficient's 1, so it makes it easier. So to get these the same, I have to multiply by 4. I can multiply by whatever I want as long as it is I do it to the whole thing. Kind of like fractions when you're getting your common denominator, you multiply it by a number. It's still the same fraction. If I reduce it, I'll get back to the original. Same here. The equation I'm going to make is going to be the same as the other equation. If I graph both equations, they would lay on top of each other. And if I were to factor it, I would get the same. I would get 3x plus y equals 5. All right, so let's take this column by column, and I'm adding. 12x plus 5x is 17x. 4y plus negative 4y is going to give me that 0 I need. Because I can't figure it out if it has two unknown variables. I got to get rid of a variable. And then this one's 17. So 17x equals 17x. Divide both sides by 17. X equals 1. Now I got to put that 1 back into one of the original equations, and I'm going to pick the first one. And you should get a 2. So my answer is 2, 1. All right. Okay, so I'm going to do substitution this time. So everywhere I see a y, I'm going to put that in. Because graphing is not the best method, I did one with graphing, I'm going to just do substitution and elimination back and forth for the rest. All right, so distribute. That's going to give me positive 15x and a positive 51. Get my like terms together. All right, so x equals 4. I'm going to put x back into one of the original equations, and I'm going to pick the second one because it's already solved for y. y is going to be a heck of a big number, isn't it? It's going to be a negative 37. So, hold on a second. Let me look at my work here. That doesn't quite make sense. I think this was supposed to come out negative. Yes, this is a negative 48, which means my x is a negative 4, which means here is a negative 4, which means it's a positive 20. That makes sense. Because I know which way my equation should go, I knew that they should be closer together. It's a positive 3. They should both be in a positive. I'm going to hit in the first quadrant. That's why it's very good to practice graphing so that you can sort of start learning the skills to visualizing where these graphs are going to go so you can catch your mistakes like I just did before you get there. Okay, so my mistake was, should have been a negative 48, which gives me a negative 4, and so on and so forth. Ooh, this one, it's elimination's turn, but I'm going to do substitution because this one is just so easy to do substitution with. Just got to plug it into there. So I'm going to deviate off of my plan and do substitution for this one. Okay, I got to subtract 6 from both sides. 4x equals 12. Divide by 4, divide by 4. X is going to give me 3. Okay, so now I'm going to put 3 back into this equation because there's no x in my top equation. I can't put it in there. But I'm still putting it in the original equation. That is very, very important. And I'm going to talk about how I can have an equation that is y equals negative 2. So my coordinate pair is 3 and negative 2. So let's talk about this. It's always best to go back to graphing in your brain. So let's graph this top one. All right, so this is my y and this is my x. Okay, if all the values for y equal negative 2, that means no matter what the x is, the y has to be a point of negative 2. Look at the type of line that this is making. It's making a horizontal line. It never touches the x-axis. All right? So then our other line, has a, let's see, what is it? Let's go ahead and graph the second line, 2. So I bring that over as a negative 4x, but then I would divide it by 3, and that is going to be a negative 6. All right, so I'm at 2, negative 3, negative 4, negative 5, and negative 6. So there's my first point. I'm going to go up 4, 1, 2, 3, 4, and over 1, 2, 3. So here is the point of intersection for the two. And I'm going to guess, since I went over 3, that this is a 3. Okay, and I'm at negative 2. I knew the y had to be negative 2 because the y can't be anything but negative 2 for the first line. So I knew I was going to intersect at y is negative 2. I just had to figure out what my x was. So really, I could have just done this first part where I put the negative 2 in for y and just called it a day and not even figure out what y is. I could have just said, I know it has to be negative 2 because this line only exists at y is negative 2. So those are just some how to do it faster tricks. All right, so we need to do elimination this time. All right, so my first equation is actually going to be this. And I have decided the best route for me, which doesn't matter just as long as you cancel out a term, is to multiply that top by 2. So I'm going to have 10x plus 2y minus negative 14. And I'm going to rewrite the second row. Okay. Alright, negative 10 plus negative 3 is a negative 13x. That goes to 0. And that is going to be a negative 26. Divide both sides by negative 13. And x equals 2. Alright, now I got to put 2 back in, and I'm going to pick the first equation to put 2 back in because it's already solved in terms of y. And that's going to be 10 minus 7, which equals 3. So my coordinate point is 2, 3, and they're both positive. That makes sense to me. Okay, it makes sense to me that they should be both positive. All right, just looking at how they would be graphed. Oh, this one's set up beautifully for elimination. So I'm going to go ahead and do elimination on this one. Because my y terms are already set up to be canceled out. Okay, so negative 4 plus a negative 5 is a negative 9x. And over here I have 27. Divide by negative 9, divide by negative 9, x equals negative 3. Now it doesn't really matter which one I put it in. I'm going to put it in the second because I like double negatives to get rid of negatives. Okay? See, this double negative here is going to make it a positive, which is what I want because I don't like negatives. Alright, I bring that 3 to the other side, and I am going to have 28. Huh. Hold on a second. That doesn't make any sense. I'm on number 7, right? It should be a negative 3. I put it into that one. Hold on, let me look at this one. Alright, so you might have saw my faux pas, my mess up, before I did. But, oh, I didn't mean to do that. But I substituted the x in for the y instead of the x. So that is what I did wrong. That I was actually finding the inverse of the function. That's a different class though. Okay, so now I'm going to subtract 15 from both sides. Okay, so 15, 5, 6, negative 6. Multiply everything by negative 1. And my numbers are negative 3, positive 6. This should have been a positive 6, which would have made my answer negative. Alright. Sorry, once you make one mistake, chances are you're going to make a ton. Sometimes it's easier just to skip the problem, come back to it later. Oh, this one's also easier by elimination. So I'm going to go ahead and do it. I'm going to multiply, you know what, let's do the top one instead. Make life easier on myself if all this is positive. I'm going to multiply it by negative 1, which is going to give me 7x plus 2y equals positive 13. Now add these two together. That's going to give me 8x. Those are going to cancel, leaving me with 24. Well, if I divide out the 8, x is going to equal 3, which makes sense. All right, so let's go ahead and substitute it back. I'm going to substitute it in for the second one, even though it really doesn't matter. It has less negatives, is why I'm going to choose to do it that way. So I'm going to subtract 3 from both sides, giving me an 8 on the right. Divide by the -2, which is going to mean that y equals a -4. So my coordinate pair is 3, -4. That's the point that the two lines are going to intersect on my graph. We're almost done part 1 of this worksheet. Okay, I haven't done substitution in a while, so let's go ahead and do a substitution on this one. I'm going to rearrange for my y on the top equation, which is going to give me y equals 5x minus 2. Now I'm going to substitute this in for y in this equation. I'm going to distribute next. Get my like terms together, which is this -3 and this, which is going to give me 27x. And I'm going to add this on both sides, which is going to give me a 0. Divide out the 27. Now, a lot of people will say, oh my gosh, this is a no solution or this is all solutions. Well, technically x equals 0. That's not a wrong answer. For us to be no solution or all solutions, to be a dependent equation or an inconsistent equation, I have to have my variables actually disappear. In this case, my variables did not disappear. So this is actually a legitimate answer. X is 0. So now I'm going to put x in this, my x value in this one, but I should see that 0 times anything is just going to be 0. So y is going to be just the y-intercept, -2. All right, so this is where they intersect. Awesome possum. Last one of part 1 of the homework video, and then I'll put 11 through 20 on the next homework video. So let's get it done. All right, let's get back on our every other one kick. Okay, I'm going to multiply this equation by an 8 so that I can eliminate. You can do substitution if you want. I didn't clarify what I wanted you guys to do. That's why I'm doing it different each time. Okay. All right, -40 plus 3 is a -37. Negative, positive, 0, and that one turns into a 0. So this is -37x equals 0. Again, 0 is a valid answer. The only time it's not a valid answer is when your variables go away. Okay, so x equals 0 again. All right, I'm going to put it into the second one. Doesn't matter. You should get the same answer no matter which one you put it in. And the answer is a -3. So my coordinate pair is 0 and -3. This is part 1 of the homework video. Watch it until you get it right. If you would like to see one of these in a different method, just email me and I'll make a video of it in a different method. And then when you're done with the first 10, do the second 10 and watch the next video. All right, happy mathing!